All right. Hello, everybody. I want to thank you all for your prompt attention and attendance here today already. My name is Chris Cogswell. I'm the moderator here for this session, customer consultant for Elsevier and chemical engineer by training. I wanted to welcome you all here today to our session on the history of bourbon production. We're really lucky today to be joined by three experts in this area. Dr. Sarah Wilson from the University of Kentucky, Devin Mills from BoozeWerks Consulting, and Dr. Bradley Berron, also from the University of Kentucky. Um, Dr. Wilson is a lecturer in chemical and materials engineering and a Beam Institute faculty fellow at the University of Kentucky. The kind of germ for this series came about because over the past 2 years, she has taught a course called Bourbon Production Engineering. Additionally, her and Brad have mentored numerous undergraduate students through research projects related to bourbon production. Professor Brad Beam is an associate professor of chemical and materials engineering at the University of Kentucky and is the research director at the James B. Beam Institute. And Devin Mills is a self-styled booze engineer. He's a visiting scholar at the chemical and materials engineering department at the University of Kentucky and a visiting scholar at the James B. Beam Institute. With that, I'll pass it over to our hosts today. Any questions you have, please throw them in the Q&A session or the Q&A section there on your screen. And with that, we will pass it right along.
All right, welcome everybody. So my name is Brad Berron, and I was going to kick it off real quick with a quick intro to really where we come from on this overall topic. So on the next slide, I just wanted to really start off by introducing the James B. Beam Institute at the University of Kentucky. And give you guys a quick overview of who we are and again, where we're coming from on this. The overall mission of the Institute is really to advance the bourbon industry through workforce education, scientific discovery, and industry partnerships. And I'll take a couple slides to just sort of show you some of the details that we use to push through there. So the biggest sort of exciting centerpiece of our institute is really the establishment of our new facility, which is actually multiple facilities dedicated to bourbon education and research. So on the right, you'll see here the James B. Beam Institute facility, which is going to have a fully functional distillery inside. We're going to have basically a good opportunity for doing both teaching and research on site on the University of Kentucky's campus. It's right there by the football stadium there. So it should be a real nice centerpiece for us to drive both research and education. And then as we do the production, we can also then take our spirits that we've produced there, roll it across the parking lot over to our 600 barrel maturation facility. So there's been a significant investment from the University of Kentucky, a significant investment from the distillery industry. And really, it's just trying to drive that overall mission of really supporting the bourbon industry in Kentucky. So on the next slide, we'll get into a little of the education aspect. We do a lot of work in bourbon education. As mentioned earlier, we have courses associated with bourbon engineering. Dr. Wilson's going to be presenting and actually hosting that course this summer. Her contact information is there if you're interested in taking a full course in bourbon engineering this summer. But we also have an online and in-person certificate available at the University of Kentucky that touches every aspect of the bourbon industry. So we've got engineering concepts brought in, particularly through these bourbon engineering courses. A lot of work in agriculture, understanding the grains, the sensory aspects, really getting into the wine production as well. That has a lot of similar concepts in terms of sensory and appreciation aspects. Bringing the basic scientists, the analytical chemistry, the biology that comes in, and also the humanities, the tourism, the craft writing, really everything that brings that entire industry together. And all that comes together in one certificate course one certificate program that really is about 12 focused hours. And we've got about 15 courses right now offered across the University of Kentucky campus feeding into this education space. And on the next slide, what we're going to see is we've got also beyond this, just sort of beyond this in-class educational experience, we've got a lot of experiential education. So we've got certificates, students going out and getting real world experience through internships and co-ops. And we've got that going with Beam. We've got it through a handful of distillers, really handling from all the way those big distillers down to the small craft distillers we see on the right there with bluegrass distillers. So on the next slide, we're going to see that we've got other opportunities in terms of how the Institute's coming through and delivering education. And we're focusing on industry education here. So what we have really pictures of here on the right is our first industry conference that we had over 500 attendees coming from all walks of life in the bourbon industry, coming in to really educate everybody associated with the bourbon industry and really get them all on a technical level that really can elevate the industry. We do both that, and we do short course programming for individual bourbon facilities as well that are interested in targeted educational experiences as well. So on the next slide, we just have one quick slide on the research program. We focus on research that impacts the industry as a whole. So we work with the Kentucky Distillers Association to try to find things that really have challenges that are industry wide. We also have partnerships with the Scotch Whisky Research Institute, but we also spend a lot of time doing confidential research with a broad cross section of distillers. So if you've got something that's confidential, we'll absolutely take those projects on. And this really sort of sums up a lot of what we have going on at the Beam Institute. So I believe at that, we hand it off over to Sarah to talk a little bit about bourbon production.
Okay, so we're going to be teaching you about bourbon production and some of the history of bourbon production as we go through the remainder of the webinar. We've broken it up into 4 different aspects of bourbon production. So the first is going to be looking at mashing. So first I'll talk to you about what mashing is, what we put into the mash. Then we go into the fermentation process where we actually produce the ethanol. Then we go through distillation where we separate out that ethanol, and then we take that and we go to the aging process. So we'll talk about each of these different aspects as we go through the presentation. So starting with mashing, what actually goes into your bourbon? So the mash bill is essentially a recipe that you use to produce your bourbon. Bourbon is always going to be greater than 51% corn. So to be characterized as bourbon, it has to have a majority of corn on the mash bill. So over the 51%, normally your range of corn in the mash bill is going to be between 60% and 80%. And you can see over here in the top right, the different types of corn varieties that can be used. Traditionally, you're going to use this yellow dent corn. So it's this yellow ear of corn where all the kernels have these little dents in them based on the properties of how it grows. That's your traditional corn that's used in bourbon production. But there's also been an increase in the use of these heritage corn varieties. So these are some of your more traditional, older corn varieties that are grown across the country. And they have a lot of these really cool flavor compounds that are produced in the kernels. And those can contribute different types of flavor profiles to your bourbon as you're going through that production. So distilleries are always trying to figure out how can I make my product unique and how can I make it different than all the other bourbon products on the shelf. And this heritage corn variety is one of the ways that they're going about doing that. The next grain that you have is going to be rye. So typically your bourbon mash bill is going to be about 10 to 20% rye. Rye is going to contribute the spiciness to your bourbon product, right? So a lot of you have probably tasted rye before. So rye is going to have your rye whiskey is going to have a higher proportion of rye, and it's going to be a much spicier product. Whereas your bourbon's still going to have that sweetness, but that rye is going to contribute to some spice to that final flavor profile. You then need to have malted barley. So malted barley typically makes up between 5 and 20% of your mash bill. The reason that we need to have that malted barley is it contains enzymes that break down the starches within the grains to make it so that we can actually produce ethanol. And I'll walk you through that process in a minute. And then you can have other grains. So really popular right now is going to be a wheated bourbon. So wheated bourbons typically are going to replace your rye with a wheat, which gives a bit more of a mellow flavor to your final product. And then again, distilleries are always trying to make a new product that kind of has some good appeal and makes it unique. So using non-traditional grains is something that distilleries are starting to do a bit more. So there've been like things like quinoa being used to give starch to bourbon products. So once you have your actual mash bill, the next thing that you have to do is prepare those grains to actually start working in your process. So again, it's like a recipe, right? So you've got your mash bill, you've got your different grains that contribute to this recipe. The first thing you've got to do is break down those grains into smaller pieces. And the reason for that is we want to pull all of the starch out of those grains. So to do that, it's a lot easier once we break them up and grind them up into smaller pieces, and that water has more access to the grains. Traditionally, the way that we're going to break down those grains is using a stone mill. So here's an example of a stone that's part of a stone mill. If you go to a lot of your really old distilleries, you'll see these stones somewhere across the facility, right? Some of them have them in the walls of their distillery, some of them have them on the ground nearby. But the way that this would work, it's just like your old flour mills used to work. You'd have your distillery near a source of water. That water would drive a wheel that would spin this millstone and allow you to grind up those grains into a smaller, more like a powder. Today, we're going to use more electricity, right? So today, typically, you're going to use things like a roller mill or a hammer mill to break apart those grains into smaller pieces. The next thing that you're going to do is go to mashing. So this is really taking all the ingredients in the recipe and cooking it to start pulling out those starches. So the first part of mashing is going to be extraction of those starches into water. And then the second part is going to be taking those starches and converting them over to simple sugars. So this extraction process, you just take all your grains, you add a bunch of water, you heat it up and you cook it. And the longer you cook it, the thicker that mix is going to get. It's going to start pulling those starches out. And it essentially, it's like oatmeal. Oatmeal's doing the same thing. It's pulling those starches out into solution. And then you convert them to simple sugar using that malted barley. So if this is what our grain is going to look like, this light yellow is going to be all of the starches within that grain. We're breaking apart that grain to be able to access those starches. So we're pulling out these starches, which are these long chain molecules of sugars. So all of these little hexagons that we've got here are different sugar molecules. We're going to cut them up using amylase. So amylase is an enzyme or a protein that's essentially like scissors for sugar. So what it does is it takes these long starch molecules and it breaks them down into simple starch or simple sugars that the yeast can actually consume. So now we've got all of these simple sugars within our mixture that make them really accessible to the yeast so that they can take that sugar and convert it over to ethanol. So moving into the next stage of the process, we've now prepped all of our grains. We've mashed our grains to extract those sugars and convert them to simple sugars. And now we're going to go to fermentation. So we take that mash, we put in yeast, and that yeast is going to convert that sugar over to ethanol and carbon dioxide. So during this fermentation process, we're doing that conversion of those simple sugars to ethanol. So this is an example of if you go to a distillery, most of your distilleries are going to have these big open wood fermentation vats, right? So as far as history of bourbon production, this has never really changed, right? A lot of your distilleries are using this old historical process of these open air fermentation vats that are being used. So you've got these big wood vats, you add all of your mash into that. So that's all of that processed grains with the starches and sugars. You add some water in, and then you dump in a bunch of yeast. And that yeast is naturally going to eat up all of that sugar and convert it over to ethanol. So when you walk into a distillery and you look at these fermentation vats, oftentimes you see them just bubbling. So when they're really, really active and really converting that sugar to ethanol, they're producing a ton of CO2, and that CO2 can be seen just bubbling out the top of your fermenter. So where do you actually go about getting that yeast? So there's different ways that this has been done, and a lot of that tradition is still being used today. So the traditional way of getting this yeast for a fermentation process is just gathering natural yeast. So what they would use is what's called a donut jug, which is this big copper jug. They would put some medium into that allows those yeast to be able to grow. And they would just take that jug with the cap off and they'd sit it on their back porch, let it sit there for a couple days and gather some of that natural yeast from like the fields nearby, things like that. So yeast would fall into it and start growing. They would then take that and smell that product, and they would maybe taste it to see, is this the flavor profile that I want? Does it seem like a good yeast came and fell into our vat? And if they're happy with that flavor profile, then they take that and they use that to inoculate their fermenters. So this is a really natural yeast production method where now they've got this yeast that they've gathered from nature, and they're using that for the production of their ethanol in their fermentation vats. Once they've done that, typically what they do is they just continually propagate that yeast in this donut jug. So every week or 2 weeks, they would take some of that yeast, put it into new medium, allow it to continue growing, and every couple of weeks they would do that. And they would put them in these copper jugs because that would protect it. If there's a fire at your distillery, you'd have these nice copper jugs that they could go and then pull their yeast out of the fire to be able to continue propagating that yeast strain for their product. So A lot of this is still used today. So there's some distilleries that have yeast strains that they've been using for 75 years with this continuous propagation method. And you can think about this just like your sourdough starters that you use to make sourdough bread. I know a lot of us over COVID with our quarantine have started sourdough bread production, right? You've got that yeast you keep in your fridge. Every couple of weeks, you transfer it to new flour. That's exactly what these distilleries are doing. But some of them have been doing this with their yeast strains for 75 years, right? So they're very protective of that yeast that they're using. The other more modern method that some distilleries use is just buying the powdered yeast, right? So you can buy yeast just like we do for making bread. You can buy that for the distilleries as well. And this gives you a really nice consistent yeast strain that some company is in charge of making. And you just buy the powder and use that to actually start your fermentation processes. There's been a lot of increase in focus on that yeast strain for improving flavor and really giving some intricacies to the flavor profile in bourbon products. So some of your distilleries might have multiple yeast strains, and depending upon the product that they're producing, they might specifically choose out that yeast strain that's going to give them that flavor profile that you're looking for. So there's been a lot of focus on that yeast side and how that's changing your flavor profiles as we've moved through with bourbon production. So now we've got our ethanol that we produce. We produce all of these different flavor compounds through that fermentation process. So now Devin is going to talk to you about this distillation stage where we start to isolate out that ethanol and the flavors for the final product.
Well, at least I'm going to talk about the easy part of distillation. So batch distillation is kind of one of the two ways that we distill alcohol, which is separating off the more volatile elements from the less volatile elements in the wash that was created during mashing and fermentation. And so basically a batch distillation is exactly what you kind of sounds like. You're going to do one batch at a time. We'll fill the still, we'll distill the liquid, and then we'll clean the still, get ready for the next batch to go in. This repeats over and over again and has been kind of going since the beginning of distillation. The other method is continuous, and that's way too technical for me, so I'm going to let Brad go over that. If you'd move on to the next one. So distilling has been around, basically forever. Started in 800 AD in the Arabian Peninsula. Basically, they were looking to use this for alchemy, trying to separate ingredients out. And it's a very simple piece of equipment. It's got basically a pot, a head, and then it flows into a reception vessel. We put this over heat, and it allows the most volatile elements to come off of the liquid first, and then be captured on the other side. The problems with doing it this way is, unless it's all dependent on how much heat you put in determines what rate things come off at. And so it's very hard to get good separation with a simple alembic still. And then we also have discovered you can really destroy things because you're putting it over direct heat. And if you've ever tried to make chocolate or something in your kitchen, you've discovered that you can really burn that chocolate if you put it right on the stove. You actually use a double boiler, which is what we did with stills. We moved over to, next slide, if you would. We moved over to bain-marie stills in the 1500s. And basically what a bain-marie is a water bath. So this is just like your double boilers that you would use for chocolate, but now this time we're doing it for ethanol. So the idea is we boil off the water in the outer pot. That steam heats the inner pot and doesn't allow the flame to come in direct contact with the still. And basically that allows you to not burn the still and get really funky, nasty, burned flavors into your final product. Again, the still in this picture was primarily used for alchemy. There was some ethanol distillation going on, but for most of the early history, we're all trying to turn lead into gold here with this equipment. The big problem with bain-marie is that you don't get caramelization. We need to get up into right around 200 degrees, a little over 200 degrees, in order to get Maillard and caramelization reactions. So there's some sugar that is not turned into ethanol by the yeast. And by caramelizing those, just like with bread, just like with your steak, we actually create additional flavors in the still that can't be replicated in any other way, which ends up creating a more flavorful whiskey. Unfortunately, The trade-off is you're more likely to burn it and destroy your batch. So we see, and we'll go through it, a transition to easier to distill, but maybe not quite as flavorful. So the next thing we started working on was the condenser. So initially, we're flowing off the still, and we're going into a vessel that basically just captured it. Whatever came over is what got captured. We didn't do any active cooling. So if you really dumped a lot of heat into your still, you could just start blowing steam out the other side. And by steam, I'm talking about ethanol vapor. What's going on here is now you have a direct fire underneath your still, and you're flaring ethanol vapor 2 feet away. And for those of you who don't know, that's a great recipe to blow yourself and everybody up around you. So the next kind of step in the technology was the worm condenser. And so this is basically a pipe that starts really large, depending on what you're doing, 4 inches in diameter, 6 inches in diameter, and then tapers as we go. That ethanol vapor starts off as a vapor, condenses down into a liquid, which means its volume decreases. So in order to keep contact with the walls, you need to have this decreasing volume in your condenser so that we can maintain contact and continue cooling it. 1700s in Germany, they invented this, and they also basically invented a way to flow cold water up past the worm. There's no exact date when somebody started taking a worm condenser and throwing it in a stream, but in the 1700s, they were actually able to get a patent for reverse circulation past the worm. This enabled it to get colder and stay colder throughout the distillation and make the whole operation a ton safer. And we could distill faster now because we weren't worried about blowing vapor out the other side. So now we keep proceeding forward. Just a short time later, we're going through the Industrial Revolution here. So bain-marie is great. We've got a pot, we heat it, it steams up and hits the pot above it. But everybody realized, well, heck, we can make steam in our steam boilers that are already running so much of the rest of our operation. Why don't we drop some steam coils down in our pot? And that's what we see in the picture here. And rather than try to, create this double vessel and make sure it's full and it's maintaining the correct amount of water, let's just run steam in through the system. So this started in the late 1700s. Here in Kentucky, the first distillery to use it was Hope Distillery. They only made it like 3 or 4 years. And the primary, well, there's a lot of reasons for it possibly to be. But a lot of the thought was this is not making quality whiskey, heating with steam. You've lost the Maillard reactions. You've lost the caramelization of the grains. Remember, we're distilling on the grains primarily here in the US, as opposed to an off-the-grain wash like we would see over in Scotland. And so without creating that caramelization, you would get less flavor. And so there were actually advertising campaigns going on for almost 100 years about, hey, we do this the old way with wood fire, and our whiskey tastes better because of that. When we got near the end of the 1800s, they basically gave up that fight, and everybody uses steam now because it's so much easier to make whiskey. So we move on. And what people did next is, hey, I need to get better booze out, more booze. And so they've started creating the doubler or thumper. And this now is in use even with continuous stills today. But the idea is that we take that ethanol vapor, we bubble it through a liquid, originally water, now sometimes other things. And that helps increase how much ethanol is in that vapor coming out. It increases kind of the proof of our spirit. The main reason to do this is now if we can get cleaner flavors out, then we can get a smaller production facility. We can get barrels that we then dilute down and create kind of more exactly the flavor we're looking for. Doublers and thumpers were created very early in the process, and they're pretty simple technology. Most times people think about them nowadays, we're talking about moonshine, people up in the hills. But in reality, this is a great method to take a very simple still with very few moving parts and start creating that additional reflux to give you a cleaner spirit. So then the next step from this is basically taking that same reflux, bubbling through a liquid, and we start doing it multiple times. And the more times you do it, the more you kind of clean up your spirit. This is a column still that was in use in the late 1800s. You can do batch methods with a column still. You just distill through your column and then clean it, repeat the process. Columns are also used in continuous production. The big issue here is you need to have enough ethanol in your pot to actually charge each of these plates. But once you do that, you can really create some clean spirits. And we start seeing people increasing the proof of the whiskey they're creating. Initially 60% ethanol was a lot coming off of your still. And by the time we've moved over to continuous with coffee there in 1830, you can basically create whatever proof you want. So that helped get people with cleaner spirits. So then on the last one, so in this kind of process, kind of where does bourbon fall? I've been talking about the still a lot. So bourbon was invented in the 1770s. Invented's a loose term. People were making corn whiskey well before that. Had a lot to do with the migration down from the principal rye regions of Maryland and Pennsylvania. But basically what they were doing was using direct fired stills, no thumpers. Condensers were, like I said, thrown in a creek. And since then, everything's changed. So until we get to the craft area here in about 2000, 2010, now people are going back and trying to find these recreated whiskeys and how did they used to do things. And so we're starting to add things back in, direct fire, thumpers, trying to come up with what's the right way to make whiskey. Why did people do this? Why were they still using fire when steam was available? So there's a whole lot of technology that has changed, and now we're kind of going back into the roots. All yours, Brad.
All right, so I'll run through modern production and try to keep us pretty close on time. But here on the right-hand side, we're seeing a modern craft bourbon production facility at the James E. Pepper Distillery here in Lexington, Kentucky. There's two major elements to the distillation process used in a traditional, in a modern bourbon distillery, and that one is the beer column. The beer column, if you look at the map on the left, it's really taking that distiller's beer that's got ethanol and water at a relatively low proof, but it's also got a lot of grains in it. We throw that into the beer column, and the beer column concentrates the alcohol, and the alcohol really comes out of the beer column about 125 proof, and then we send it over to a doubler. And the doubler is the thing circled in the red there, which looks more like a traditional pot still. And that's really just going to concentrate the alcohol a little bit further from 125 proof to 140 proof. So this is the Pepper Distillery. On the next slide, we'll see the same exact process really at the Kentucky Peerless Distillery. It's slightly larger here at the Kentucky Peerless. I think it's like a 16-inch column. But what we're going to see is really these columns go up pretty high. I mean, we've got these massive columns that really handle this job. But again, sticking with this beer column and doubler process is really what generally is used in modern production. So on the next slide, we'll dive a little bit into the beer column. And what you might have noticed on the previous pages and really on this picture here is a lot of these pictures, if you look at these little windows that allow you to see into the still, a lot of those windows look yellow. And as you sort of look at some of these blown up pictures there, you can see that the yellow is actually the grains coming in along that system and really the grains getting fed into that column. And in the bottom half of that column, you really see it's yellow because those grains are predominantly corn. So they're sort of splashing up against that window, and you can kind of see the grains working their way down. And in the general flow of this still is that grains and water are going to be moving their way down, and ethanol is going to be moving its way up. So if we look above where that distiller's feed comes in the middle of that left picture, you'll see the windows up above that are just sort of dark. So we're not seeing those grains splashed up against there. That's largely just ethanol moving up. So on the next slide, what we're going to kind of see is really the general two sections. And this is how engineers oftentimes look at distillation columns. It's really what's above the feed pipe, concentrating the alcohol up to 125 proof. Like Devin was saying earlier, sort of acting like mini stills, concentrating that alcohol and cleaning it up as it goes up. And then below the feed pipe, we're going to see it's really the large purpose down at the bottom. That huge section of the column, probably 20 to 25 foot of that column, is really to try to strip all the alcohol off the grains and get to the point where almost all water's leaving at the bottom with the grains, and we're not losing any alcohol with our spent grains. So next slide. So how that works is really what, if we think about what's happening in the column, is the vapor, if we think about vapor being steam, pushes its way straight up through the middle of the column. So the vapor path is just shooting straight on up, and that's really that enriched alcohol that starts to sort of like be the steam leaving, or the vapor leaving the pot still. That same kind of idea. The liquid is sort of the green arrows here. That sort of takes a serpentine path down. It basically comes down a pipe and then shoots across these trays. And during the trays, the vapor and the liquid are mixing, and then it shoots down another pipe and mixes again. So the liquids and the solids are going to sort of take the serpentine path down, and we can see the inside of the column on the very next slide. So what's happening on this on each individual tray is we've got these little trays, and you'll notice there's holes, and that's actually where the vapor is sort of just shooting straight up the column. So we've got vapor pushing up through these holes, but then we've got liquid on these trays as well. So the liquid rushes across this tray and then spills into that pipe and goes down to the next level. And what's really happening there is, if you think about basically having a pot of water on your stove at home, if you let that boil and you've got a lid on it, your lid's going to start dancing around and jittering around, and that's the pressure of the steam and the vapor is coming up that's really pushing up. So really those holes on each tray are small enough that really all we're doing is allowing that steam pressure and that vapor pressure to push up and keep the liquid from falling through the holes. And that's really how we get good mixing of vapor and liquid on each tray, and how we can turn those little layers into mini stills. So on the next slide, we look at our overall process. We really sort of covered a little on the beer column and how that works, and we'll revisit the doubler in this very next slide. So the doubler, sort of the difference between a doubler and a thumper that Devin was hinting at earlier, is really the doubler is going to have a little extra heat thrown at it. So we've got a little steam heat coming in at the bottom of this doubler, but it's usually a relatively small pot still that's run continuously. It takes 125 proof low wines and turns it into what is 140 proof high wines coming out the backside. And really that's just enriching the system a little bit further. So on the next slide, we can see basically an overview of modern distillation using a doubler and a beer column. And the big thing I want to point out here is in the background, this is Harlan Wheatley hanging out at Buffalo Trace Distillery, major distillery operation, but you can see in the background is a beer still. So you can see this big wrapped insulated column, 6 foot wide. Where the ones that we have at our institute at UK is going to be about a 1 foot wide column, but the same basic process is used all the way across bourbon production in Kentucky using this one traditional approach. So I'm going to turn back over to Sarah to talk a little bit more about the aging after it leaves the still.
All right, so now we have our ethanol, our flavor compounds, and a little bit of water. And what we're going to do is take that into aging. So just our last slide here, going through aging, what's actually going to happen. So your product from your distillation is first going to be proofed down. So what you do is you mix your product coming off the still with some water to get it to the proof that you want to go into the barrel. And then you're going to put it into a new charred oak barrel. So for it to be called bourbon, it has to be a new charred oak barrel. Otherwise, you can't recycle your barrels with bourbon production. And then you're going to put it into a rickhouse to age it. There's no actual age restriction for length of time that the bourbon has to be aged. If it's aged less than 4 years, you've got to have it labeled on the bottle that it's aged less than 4 years. But we all know the longer that product is going to be aged, typically the better the flavor that's going to develop over that time. So you can also vary the char level in the barrel. So what they do is they take these oak barrels and then they char the inside to get some of those caramelization flavors that Devin was talking about. So just like with your bourbon, you want to char or caramelize some of that flavor. Here, you're going to caramelize the wood to contribute that flavor to the barrel. And what's going to be happening as you're going through this aging process, you're going to be extracting a lot of flavor from the wood. So your product is going to be soaking into the wood, and as it goes through temperature fluctuations, it's going to soak into the wood and then go back into the barrel. And that's going to allow for extraction of flavor from the wood into your product. And then you're going to get evolution of those flavor compounds. So a lot of those flavor compounds from the still are going to mellow out over time and give you a really much more diverse flavor profile. And then the last thing that's happening during that process is what's called the angel share. So you actually get evaporation of your product through the barrel. So typically that's going to lead to an increase in the proof of your product. So more water is going to evaporate than ethanol, which increases the proof of your product. and gives you that really nice, yummy smell as you go and walk through a rick house. So with that, you have at the end of that aging process, you've got your final product, right? All you're going to do then is adjust the proof and throw it into your bottle for actual sales. And with that, we've walked you through kind of the bourbon production process with some history involved in that. If y'all have any questions, feel free to look up our contact information here, but I will hand it back over to our webinar leaders.
All right, thank you all so much. It was absolutely fascinating. I'm a little bit upset that it's only noon here where I am, because now I feel like I need a drink. Thanks everybody for attending here today. We're gonna go ahead and start a poll. Just quickly, if you could answer that, that'd be a real help to us, so we know, if sessions like this are of interest, if we want to do more of them in the future. Another thing I'd like to point out for everybody is we do have a YouTube channel now where we host where these kind of events that we've done before, Elsevier for engineering. So please check out that YouTube channel. We take a look at different kinds of questions and things like that. And yeah, it looks like everybody thought this session was interesting and would like more of this in the future. So really great. Thanks everybody so much. Are there any questions? Let's see. Oh, someone just saying great presentation, which it absolutely was. A very, very interesting one. One that I know I had when I was listening to this was, so what is that time period between, like, obviously aging is the bulk of the time for this production method, but how much time does it take to get from like, initial mash to final, like when you're going to start aging things?
So it's a pretty quick process. Usually the grind goes pretty quick. So yeah, really just sort of crank through the grind. I mean, you're cranking through enough grinding for a cook in a matter of an hour or so, and then the fermentation is probably your biggest step. Fermentations are basically staggered so that you constantly have new distillate ready to go. And most distillers do somewhere in the range of a 3 to 6 day fermentation. So it's really that fermentation lag step that holds it up the most.
Sure.
So, but those fermenters are sized and numbered in a way that you can get them through and keep your still operating 24/7. So yeah.
Sure, that's really interesting though. So we actually had a question here in the chat. So what is significant about that 4-year aging mark?
Mostly it's the law. So when they started defining bourbon and whiskey in general in this country, a lot of the research was all done by the IRS, primarily trying to create excise taxes. And so along the way, they've created a lot of categories. What is bourbon is defined by the government. And we have things like the Bottled and Bond Act that have all done different categories along the way. It has less to do with the flavor of the product than it really does with meeting certain legal categories. So the difference between a straight whiskey and a bottled and bond whiskey is time for the most part, but there's some other idiosyncrasies, but it's all defined by the government.
Okay, so like with everything, it is taxes that determine that.
That's the secret to whiskey in general.
Very funny. Cool. Okay. Another good question here. So during the open vat fermentation, are you losing ethanol?
So you're going to lose a little bit, but nothing super significant. They try to control the temperature pretty well as you're going through that fermentation process to keep the yeast happy, but you're mostly losing CO2. A little bit of ethanol is going to go out the top, but nothing too crazy. They're just trying to get you, they go through that fermentation process fairly quickly to be able to get to the still. So their final concentrations coming out of that fermentation process is going to be pretty low, around 10% coming out of the fermentation, going into the distillation process. And you don't lose anything too significant over that period of time.
Really interesting. Okay. Another one here I have to get in because I think it's a very good question. Your favorite current whiskeys or bourbons, and any suggestions on sleeper bourbons that people should try?
Well, as the only non-Kentucky person on this panelist, I'm going to throw in a Colorado bourbon Law's Whiskey makes a 4-grain 6-year that I very much enjoy, just to pull us out of Kentucky before everybody else comments.
My usual go-to is a Four Roses small batch. I like that one a lot. And as far as sleepers, I'm going to hang on to those. I want them on the shelf when I need them. So.
Yeah, and I think I've stolen from Brad the Four Roses small batch is amazing, but also I really like Angel's Envy. But I'm not a bourbon connoisseur. I'm fascinated by the bourbon production process much more than I am I'm not a bourbon snob when it comes to drinking it.
Very cool. Okay. And we're going to do one more question here. There are a lot of them here. So what we'll do afterwards is we'll pass them along to you all. And thank you everyone for your questions. These are really great. One that I think is really interesting is, let's get two in there quickly. When will the Still on the Campus produce its first barrel, or when do you anticipate that'll happen?
May 2022.
May 2022. Okay. So be in Kentucky, May 2022.
4 years after that.
Right. Well, actually, that's a good point. 4 years after that, right? Because the barrel will be produced, then it has to age. And okay. And another one that I think is actually really fascinating here is craft distillers. You mentioned that craft distillers are bringing back kind of historical methods. Is there any general kind of consensus or idea that these methods derive a better product, or like what if we were going to taste those, or if we were looking for those, what should we anticipate we would notice as a difference?
No. So we don't know anything. We lost so much knowledge during Prohibition. And so the chemical revolution basically occurred during Prohibition. How we analyze chemicals changed. And so a lot of the historical knowledge of what we did in the late 1800s, early 1900s doesn't match to what we know about chemistry today. And so translating what we used to get with what we get today just really doesn't work. So Brad and I are working on a project right now to recreate a historic still that existed in the late 1800s and match its chemical profile to what we have in the records, and try to figure out, can a still designed today create flavors like existed in the 1800s? Some of those whiskeys have survived through Prohibition, and so eventually we're going to do a taste test to see if it still tastes the same. But quite honestly, no, we don't know what we're going to get. People at the time have commented, and you can find records that says, oh, this is better than this. But, do palates change over the last 140 years? Probably. So better may not be actually better. So I have no idea how to answer that question.
No, yeah, we've gotten kind of into the realm of deep metaphysics now, right? What is flavor? But really interesting. Thank you all so much for your time. Thank you everyone who attended here for your attention. Everyone just loved this session to bits, it looks like, so we will definitely have to do another one. Please, if you are interested, feel free to reach out to any of our hosts here today, or you can always send us an email too through Elsevier, and we're happy to kind of get people in contact.